Hello and welcome to Unit 8, Part 6. My name is Mr. Bell and we're going to talk about arithmetic and geometric sequences today. In these two examples it says, is the following sequence arithmetic or geometric? Then identify the common difference or common ratio. And that kind of answers the question for us, what are arithmetic and geometric sequences? Well, arithmetic sequences are ones that change by a common difference. A common difference. Meaning you either add the same number each step or you subtract the same number each step. It's a consistent common difference. If it's a geometric sequence, it is changing by a common, what's called a ratio. That means you are either multiplying or dividing by the same factor every single step of that particular sequence. So let's see if we can answer these two questions based on what we just learned. Number one, it goes from 2 to 4 to 8 to 16 to 32. First, let's identify how is it changing. And sometimes you have to look at more than one step or member of the sequence to tell that. From 2 to 4, we both added 2 and we multiplied by 2. So it could be either one after that first step, but let's continue to see which pattern continues. Well, from 4 to 8, we did not add 2 again. This time we added 4. So that tells me that there is no common difference. But from 4 to 8, we also multiply by 2. And then if we take 8 and multiply it by 2 again, we get 16. Times 2 again would be 32. So that tells me that this one is a geometric sequence, and the common ratio is 2. We are multiplying by 2 each step of the way. Question number 2, we're going from 8 to 14, which is an increase of 6. And before I try to figure out what multiplied by 8 gives you 14, let's see if that plus 6 difference continues. Well, 14 plus 6 is 20. 20 plus 6 is 26. I think we can agree that this time our sequence is arithmetic, meaning we have a common difference every step of the way. And what is that common difference? Well, it's a difference of a positive 6 each step of the way. On this slide, we're asked to use the correct formula to find the 10th term in a sequence. Well, there are two formulas. There's the arithmetic sequence formula and the geometric sequence formula. And what we're going to do is we're going to look for some key parts of each of these questions, plug them into one of the correct formula to find the 10th term in the sequence. And I know some of you will say, oh, well, I can just look at the pattern and count out to the 10th term. The formulas really come in handy when you're looking for the 1000th term or the 1235th term. You don't want to count out 1,000 different steps of this sequence to figure out what that number is. These formulas will make life much easier for you. So starting with number 3, let's see if we can figure out the pattern. From negative 3 to 6 would be a plus 9, or we could multiply by negative 2. So both of those work, either adding 9 or multiplying by negative 2. Well, from 6 to negative 12, I did not add 9, but 6 times negative 2 would give me a result of negative 12. Negative 12 times negative 2 would give me a positive 24. So I have found that this is a geometric sequence, meaning I'll use the geometric formula. And here's how that works. If I'm looking for the 10th term in the sequence, A1 represents the first term in my sequence. Well, in my sequence, the first term was a negative 3. The R represents the ratio. Well, the common ratio in this particular problem was we multiplied everything by negative 2. And then we have an exponent of n minus 1, and n represents whatever term we're looking for. So in this case, we're looking for the 10th term, and then minus 1 is what the formula says to do. So I can evaluate this in the calculator or by hand if I wanted to. The 10th term will be negative 3 times negative 2 raised to the 9th power. That's when I subtracted 10 from 1, giving me a result of 1,536. So the 10th term in my sequence that starts at -3 has a common ratio of -2 would be 1,536. Let's try this on the next example. From -5 to 0 we added 5. And before I try to figure out what the multiplication might be for a ratio, let's see if +5 continues, and it looks like it does. It looks like we add 5 in each step of this sequence. That tells me that number 4 is an arithmetic sequence. Well, let's apply that formula. The 10th term in my sequence would be my first A1 is representative of my first term in the sequence, which was -5. Then I've got to add the D in this formula represents the common difference. Well, my common difference was a +5. And then N, again, is whatever term I'm looking for, which in this case it is the 10th term -1. So let's see if we can figure out what our 10th term in this sequence would be. -5 plus 5 times 10 minus 1 is 9, giving me -5 plus 45. So the 10th term in my sequence here would be 40. So if my first term was -5 and our common difference was +5 every time, the 10th term in this particular sequence would be 40. So just keep in mind that you have to determine which of those two formulas to use and then plug in the components to figure out that particular term in the sequence. All right, thanks for watching and hope this helps.